Assalamualaikum and good afternoon. My name is ALISA MAISARA BINTI NORAZMI from 4C. My metric number is 2025-380971. Today, I will be presenting about assignment 2 titled Movie Inventory.
In my previous work, I used the array list and the fundamental linked list. Today, I'm presenting my movie inventory application by using another structure which is queue and stack that inherit directly from the linked list. Now, let's start with the queue class. It follows the FIFO, which is first in and first out. That means the movie that arrives first is the first to be processed. This code used to inherit from the linked list to reuse the code to the queue. An enqueue code used to put the movie at the end of the line by using insert at back. The queue code is used to take the movie from the front by using remove from front. GetFront method is used to look at the item currently at the front of the queue without removing it. Then, the getEnd method is to look at the item at the end of the queue. To do this, it removes the last element by using remove from back and then immediately reinsert it by using insert at back to restore the queue state before returning the object. isEmpty method is used to check if the queue currently contains any item. Next, proceed with the stack class. As I said before, this code uses inheritance from the linked list to reuse the code to the stack. Push code is used to put the movie right on top by using insert at front. Pop method is used to take the top movie off by using remove from front. Pick is used to inspect the top, which is read only and not changing it or remove it. Alright. And isEmpty method is a standard helper method that is used before attempting pop or pick to prevent errors. It returns true if the stack contains no element. Now, both queue and stack call the parent linked list method to retrieve the element. Let us proceed with the movie main class where the application logic runs. First, I read the movie.txt and loads all the movie object into the move list queue by using enqueue. And this is the example of movie.txt. Then I start with the statistic analysis where I need to find the sum, average, mean, and max by using queue. Since we are using queue, I create a temporary queue to read and process every item in the original queue without deleting them. This technique is necessary because of the fundamental rules of a queue. Before I start to find the sum, average, mean, and max by using queue, I display all the movie contained in the move list queue. Then I move the data in queue temp to the original queue by using enqueue method. Now, I start by calculating the total number of horror movie duration. As you can see, I move the object from move list to the queue temp by using enqueue. Then I filter the movie by using horror genre to get the total horror duration. Then I display the total number of horror movie duration. After I calculate it, I move the data in the queue temp to the original queue as before. And this is the output. The total number of horror movie duration is 250 minutes. Then I calculate the average movie duration by tracking the total duration in the move leaf, then calculate it by dividing the sum by the total count in the move leaf queue. As you can see, I do the same for all analysis to move the data back in the queue temp to original queue. For min and max, I simply compare each movie duration to the current highest and lowest value. And this is the output of average duration of a movie, which is 132.8 minutes, and the lowest and the highest duration of a movie is 92 minutes, which is the Final Destination 5, and the highest duration of a movie is 181 minutes, which is the movie Avengers Endgame. After I find the minimum and maximum movie duration, I copy object data from a queue to another queue. This could copy action genre movie from the main queue to a new queue, which is action queue. And the output of the data in action queue is 3. Last but not least, I will show you the expression conversion class that shows the stack converting mathematical formula. For this class, I convert in-fix formula to post-fix. As you can see, I use the stack to hold the operand. Then, I use for loop to iterate over each character in the post-fix expression. Then, if the character is a digit, it will push it to the stack. If the character is an operator, it will pop two operands from the stack. Then, it will perform the operation and push the result back to the stack. Then, the result of the expression is the last element in the stack. Then, this is the method to convert an if expression to a postfix expression. I use string builder to hold the postfix expression. Then, I use tab to hold operator and the parentheses. This for loop is to iterate over each character in the infix character. If the character is an operand, it will move it to the back of the final result string. And if the character is open parenthesis, it will push it to the stack. And if the character is close parenthesis, it will pop and append it from the stack until open parenthesis is found. It will remove the open parenthesis from the stack. Other than that, if the character is an operand, pop and append from the stack while the precedence of the operator is less than or equal to the precedence of the operator at the top of the stack. Then it will push the current operator to the stack. Lastly, it will pop all remaining operator from the stack and append it to the result. As you can see, this is the method to define the precedence of operator. I refer this code from the website, which is Jig4Jigs. Then I use this code to convert my infix expression to postfix expression. Next, I will test the functionality. My infix expression is 120 divided by 4 plus 90 minus 5 multiplied by 3 minus 24 divided by 2. And now I will show you the postfix expression. As you can see, I have successfully implemented the expression conversion from infix to postfix expression. That's all from me. Thank you.